Hey dudes, sorry I'm not here, but this is why. We're gonna do some math. It'll put you to sleep just like this. So I'm gonna be a little bit quieter than normal, and if I have to do some splicing, it's because somebody's pooped. Alright, so here we go. We're checking out 6.4, finding the area of triangles and things with trigonometry. And in the warm-up, what I'd like you to try to do is pause me for a second, and I'd like you to find me the area of these pieces, just these chunks, okay? You know the general idea. Pause me and go for that, yeah? Try it. Alright, so when you're looking at area, really the area of this means you have 5 strips. I'm running with one hand, as you can see, so you might have to speed me up. So you have 1, 2, 3, 4. So you have 5 pieces here and then 8 pieces here. And if you count them all up, that's what the area is, right? You get 40. Right? Well, this is going to be painful, isn't it? You get 40. The area of this is, it's not 3 times 4, right? Because that would be a box this big. The area is only half that. So it's 1/2 base times height. Yeah, so it's 1/2 of 3 times 4, it's 6. This thing is the same thing, even though it's not a right triangle. It's 1/2 base times height. So it's 1/2 times 6 times 4, right? So it's 3 times 4, so this thing has an area of 12, right? This piece might be too complicated for me to do with one finger, but you get the drill. This is 1/2 base times height, so 20, so this piece is 10, right? This is half of 15, right? 15, 5, and 3, so this is half of 15, so this is 7.5, and this is 30, and you'd add them all up. Great, fine. So that's the idea from area. We'll check out some homework next time I'm here with you, which will be next week. Today I want you to be able to walk away being able to compute the area of triangles using AB sinus C. It's sort of a trigonometric equation, yeah? And that's what Leonie wants of you too, right? Yes. Great, fine. So previously to our awesomeness in Trig, we've been using the, oh yeah, you think so? We've been using area as 1/2 base times height, which we used in the warm-up. And so 1/2 base times height, that's easy to see with these down here because this is half of this square, right? And if you were just looking at the square, you'd have base times height. It gives you the whole area, and this is half of it. You can see it half there. That's not a big deal. It even applies when it's not a right triangle, right? What's inside here, if you pull this out and flip it around, right? Almost. Yeah, one-handed, there you go. If you double what's here, you get the whole rectangle. So if you only have half of it, it's 1/2 of that rectangle, regardless if it's a right triangle or not. But you need to know this base length and this height. And you can write it here, or you could write it here. But you got to know that it's a right angle to the base, goes all the way to the point. Yeah, 1/2 base times height. So take that idea and find me the area of these two triangles. Go. Go. All right, so this guy is the same sort of thing. If you made this whole thing into a square, you'd have half of this piece and half of this piece, and so you could use area as 1/2 base times height. It's old school geometry, no fail, super easy, but boring, right? So it's taking me so long to write half base times height. The base is 6, the height is 8, so it's 3 times 8. Great, right? 3, because I'm cutting the 6 in half, so 1/2 times 6 times 8. Ching, not a problem. This one doesn't work as well like that because it's not a right triangle. It doesn't show us that this is a right angle, so we can't rely on it being a right angle. This one isn't a right angle. So we're stuck in the water here. Yeah? You want to give me a cry? Not crying about it, because we have trig on our side. And so what we're going to learn how to do is attack this using trigonometry. And the whole idea is this, just like in 6.3, when we took the triangle and we dropped a height down, we broke these into right triangles, and then we solved using that. You can do that every time. Break it down. It'll always work, but it'll always be slow. So we want to build a formula that's efficient for us. So we're going to try that. You ready? Yes. Yes. Okay, great. So let's go. Bam. So this is the derivation of the formula for the area of a triangle using some trig. You don't necessarily need to know the derivation. I just want you to see that it's not the math gods who gave it to you. It's Leone, right? You can derive it from what you know. So the area of a triangle is 1/2 base times height. Not a big deal. We saw that here. Being 1/2 base times height. So that's what this piece is. Area is 1/2 base times height. And so with this, if we use this triangle, this setup, notice that you have this vertex is A, and the side across from it is always going to be the same letter, but this lowercase A. So A and A. Here's C and C and B and B. It's always going to be like that. That's just the general rule for how to write those down. So then you can relate them. You know that A is always on the other side of the triangle from A, right? Point, side, right? So if we're looking at area as 1/2 base times height, in this case, the base is A, and the height is H. It's not a side, right? Great. So instead of calling it base times height, I called it A times H, right? This used to stand for base, not necessarily this side, B. So 1/2 A times H. All right, fine. Like we saw yesterday, we can give H a different name, right? We can call H H. We can also relate it in terms of this angle. So if you think about just this triangle, I'm going to try to make this and pull it out for us. Like that. There it is. And so if we pull it out over here, this bottom angle right here was C. This side here was H, and this is B. Yeah, this was a right triangle. If you used some trig on this, you can say, well, fine, sine of C, sine is opposite over hypotenuse. It's H over B, yeah? So that's this piece. And what we're going to do is give H a new name and insert it in a second, right? So sine of C is height over B. If we rearrange this for height, if we take B, we multiply B over here, we multiply B over here. I can't believe you're waking up. You're not waking up through all these. These B's cancel. And you're left with this. Height is really B times the sine of C. It's just another way to talk about H without knowing the side lengths, right? If we know B, we know the sine of C, we've got H. And what we can do now is take this mess and put it in here for H, right? And so now you got this. Area is 1/2 side A times side B times sine of the angle C. So it ends up using this piece, side A, this piece, side B, and the angle between them, C. And we've derived what they call the area formula using sine. You'll see area is 1/2 AB sine of C. And all it means is if you know two sides and you know the angle in between, you can use this trick where we break it into right triangles. Except we don't want to always have to break it into right triangles. What are we? 4 days old? We got better things to do than that. Yeah, I know, dude. So really what we've made is a formula to be able to do this more efficiently. So if you have two sides and the angle between, use 1/2 AB sine of C, and you can find the area. Cool? If you're confident in the derivation and you'd like to show me on an assessment, I'd give you some EC, or I'd give you some extension points for that, making some 7 and 8 headway. Cool? Cool. All right. So, great. Okay, so here's an example. We want to try to find the angle of, this should be EFG, not ABC. So find the area of the triangle. Great. Well, I've got a side, I've got another side, I've got the angle in between, which means I can use 1/2 AB sinus C. Ching. If not, maybe you have to find those pieces, right? Maybe you have to find this angle, but they've given us all the pieces. We've been spoon-fed because you're new at this. So I'm going to take the pieces that we know and say, okay, well, this is 1/2, one of the sides, 15, the other of the sides, 11, times the sine of the angle between. Make sure your calculator's in degrees when you calculate sine of 28, and you should get 38.7. Plug this in your calculator right now and make sure you can get 38.7. If you can't, you're not having trig problems, you're having calculator problems. So go parentheses 1/2, 1 divided by 2, right? Close parentheses, times 15, times 11, times sine of 28, close parentheses, enter. You get 38.7. Cool? Once you got that, try this one on your own, right? Find the area of this piece. 5, 6, sine of 50, 1/2 AB sinus C. Go. All right, same idea. 1/2, we plug in the pieces that we know, 1/2 AB sinus 60, and you should get 13-ish, right? 12.9. Like stealing candy from a baby. Great, fine. That's the idea. Now, it might be that they mess with you a little bit. They're like, oh, this is, oh, I don't know this one, but this is 70 degrees, right? And, oh, that's an awful 7. Sorry, man. That's 70 degrees. And, oh, this one's 12 degrees, right? So then you have to find this on your own. Not a big deal. You say 180 minus 70 leaves you with the missing side. So sometimes you're going to have to fight for a little bit to be able to use the formula, but I know you can do it. Great, fine. That's it. That's all. If you're feeling like a champion and you run through this homework and you're comfy with it, check out the extensions on arc length and sector area. The arc length is this length on a circle if you're given an angle, and the area is this area of the slice of pizza that you get. They're important in SL, so if you're gunning for SL or you're pushing a 7 and 8 for 7s and 8s, figure out how to calculate those. There are videos on the VLE. They're Khan Academy. They're not mine, but they're good and they're simple. It's not real hard. It's a proportion. You're just building a proportion, right? There's practice problems on the VLE and there's answers. Try those and show them to me when you're done. Cool? So, yeah, what do you think? That's it. Here's your home learning. It's up on the VLE. It's not a ton of problems, and if you get done, try those extensions. I will be back next week, and we'll go from there. Cool? Snore goodbye, Leonie. Goodbye.